In this video, we're going to work example problems related to the domain and range of trig functions. Now, these problems won't strictly be just about trig function domains and ranges. These problems come from section 1.4, which we went through in the last video. And so also mixed in will be problems related to the sign of trig functions, like whether they're positive or negative, given certain information about the angle, like what quadrant it's in, etc. As well as we'll work some problems related to the trig identities that we developed. So the reciprocal identities, Pythagorean identities, and quotient identities. Okay, so let's get started. Let's fill in these blanks. Given cosine theta is 1 over secant theta, two equivalent forms of this identity are, so yeah, with any reciprocal, you can multiply both sides by secant theta, and what does that result in? That results in cosine theta secant theta is equal to 1. So that's, we can put that here. Okay, but then here we can divide both sides by cosine theta and get this. Given tangent theta is 1 over cotangent theta, two equivalent forms of this identity are, so yeah, same thing. You can multiply both sides by cotangent theta and get this. Now you can divide both sides by tangent theta and get this. For an angle measuring 105 degrees, the trigonometric functions blank and blank are positive, and the remaining trigonometric functions are negative. All right, so when you're thinking about is a trig function positive or negative, what you're thinking about is what quadrant is the angle in. So 105 degrees is going to be in the second quadrant. Okay, so with that, now that you know the quadrant you're in, you just think about for any angle, the right triangle that would be drawn. You know, any right triangle is going to, you're going to make this leg here, the y leg, is always perpendicular to the x-axis. And so with that, you can see what the signs of the legs are going to be. The hypotenuse for any quadrant is always positive, but you can see the signs of the legs are going to have a negative x and a positive y. So which trig functions are positive? Well, opposite over hypotenuse, sine theta. And the reciprocal of any trig function is going to be the same sign as long as the angle is the same. So what's the reciprocal of sine theta? That's cosecant theta. And the rest are going to be negative. Adjacent over hypotenuse is negative. That reciprocal is negative. And then the tangent opposite over adjacent, that's negative, and so is its reciprocal. If sine theta is greater than 0 and tangent of theta is greater than 0, then theta is in what quadrant? Okay, so if sine theta is going to be greater than 0, then the opposite is going to have to be positive, because you can't have a negative and a negative with sine because the hypotenuse is never negative. And the opposite is always the y value, because we're always, for any quadrant, we're drawing the right triangle to where the y leg is perpendicular to the horizontal axis. So for sine theta to be positive, you're going to have a positive y, which is quadrants, this is quadrant 2, quadrants 1 and 2. Okay, now if tangent theta is going to be positive, then tangent theta can't be positive here. It's only positive in the first quadrant, so theta must be in quadrant 1. Okay, determine whether each statement is possible or impossible. All right, sine theta is equal to 1/2. All right, well, we talked about how the range of sine theta is between 1 and -1, including -1 and 1, and then, but there's no restrictions anywhere in between that. Like it's not like it can only be integers or something, so it can be absolutely, sine theta can be, and cosine theta can be absolutely anything between -1 and 1, including the endpoints. So this is possible. Okay, cosecant theta, with secant and cosecant, we talked about those are kind of the hardest, probably the hardest to understand their ranges, but remember those go from, you can have any value from -infinity to -1, including -1, and then anything from 1 to infinity. And as far as the specifics on why this is the case, go check out the lecture video. We talk about this in detail. But so you can have 2 is within this range, right? So this is also possible. Okay, and I think actually what they're saying is that we need to look at this statement as a whole. So, okay, both of them are possible individually, that's fine, but can they both be possible at the same time as well? So yeah, if one of them by itself was not possible, then all of this would be not possible, but can we have this taking place at the same time? Well, okay, what's the reciprocal of sine? It's cosecant. Well, then, yeah, they're going to be, you couldn't have this. That's not possible for the same angle. That's not possible. Even though you can have cosecant theta b minus 2, we can see that. But here, the reciprocal of 1/2 is 2, so yeah, this is possible. Okay, you see, no, this is not possible. Like, these can't take place at the same time. You can't have sine theta be greater than 0 and cosecant theta be less than 0 at the same time. Why not? Because these are reciprocals. Reciprocals have the same sign. So how could you possibly have sine theta be positive and cosecant theta be negative? You can't. Even though cosecant by itself, if the thetas were different, cosecant could be negative. Okay, cotangent is negative 1.5. So what do we know about the range of cotangent? Well, it's just like tangent. The range is, you can get any value from negative infinity to infinity. Cotangent or tangent, the result could be any value from negative infinity to infinity. And again, I'm not going to go into specifics on why that is here. We talked about that in detail in the lecture video. So yes, this is possible. You can have just cotangent of an angle by itself, could be anything. Okay, use the appropriate reciprocal identity to find each function value. Rationalize the denominators when applicable. So yeah, this is easy. In the previous section, we didn't work examples just like this, but we found values of secant and cosecant and cotangent by just flipping the sine, cosine, and tangent values that we evaluated. So if we know cosine theta is 2/3, then what is secant theta? Since we know secant is the reciprocal of cosine, secant theta is 3/2. Just flip it. It's the reciprocal. Okay, cosecant is the reciprocal of sine. So cosecant is minus 7/3. And it's that easy, unless whenever you flip it, you're dividing by 0, then you just say undefined. Okay, tangent theta is 5, so cotangent of theta is 1/5. Okay, cosecant and secant are reciprocals. So if we know that secant theta, cosine and secant are reciprocals. If we know that secant theta is minus 5/2, then we know that cosine theta is minus 2/5. Okay, cosecant and sine are reciprocals. So if we know that cosecant of theta is √8/2, then sine theta is 2/8, but they want us to rationalize the denominators when applicable. So we don't want to have a radical in the denominator, so we multiply by √8/8. And this is 2√8/8. Okay, 8 is 4 times 2, so you take out the √4, you get 4√2/8. So, okay, sine theta is √2/2, which is still just the reciprocal of this. Okay, if we know cotangent theta is minus 2/5, then it's just going to be minus 2.5, then tangent theta is going to be minus 1/2.5, but we can put this as a fraction, so minus 2.5 is minus 2 1/2, so that's minus 5/2, so this is minus 5/2, so tangent theta is minus 2/5. Okay, cosecant and sine are reciprocals, so if we know that cosecant is 1.25, then sine is going to be 1/1.25. What is 1.25? That's 1 1/4. That's 5/4. So this is 5/4. Therefore, sine theta is 4/5. Okay, what is wrong with the following item that appears in a trigonometry test? If you were asked, find secant theta, given that cosine of theta is equal to 3/2. Well, secant and cosecant are reciprocals, so that means that secant theta is 2/3, right? No, this makes no sense. Cosine can't be greater than 1. 3/2 is greater than 1. What's wrong with this statement? So tangent of 90 is equal to 1 over cotangent of 90. Well, the issue is, what is tangent of 90? Well, if we think about, so as we're coming into 90, what's happening? The x is going to 0. When you get to 0, the x coordinate is equal to 0, the opposite over adjacent. You're dividing by 0 here. This is undefined. So there's no, you can't do, like they talk about the trig identity. So here's a reciprocal identity. You can't use the reciprocal identity unless the function is defined, the theta exists, right? You can't say tangent theta is equal to 1 over cotangent theta. Yeah, this is true, assuming that the theta you're plugging in, the function, like you're not dividing by 0, there's no issue with it. Like the equation is defined. Like for the identity to work, you have to plug in a theta and you get this is equal to this, right? If we plugged in theta is equal to 45, we would get this number is equal to the exact same number. But if we plug in theta is equal to 90, this doesn't work. Okay, determine the signs of the trigonometric functions of an angle in standard position with the given measure. Okay, so here's the angle. We want to know what are the signs of the trig functions. Well, when it comes to just the signs of trig functions, what we're thinking about is what quadrant are we in? Here, we're in quadrant 1. So a triangle, any right triangle is going to look something like this. Okay, no matter what the quadrant, this is always positive, but in the first quadrant, both legs are also positive. So every single trig function, when it comes to the first quadrant, is going to be positive. So anytime we have an acute angle, every single trig function is going to be positive. Because they're all just ratios of the sides, right? But all the sides are positive in this case. Okay, 178, we're in the second quadrant. We're like down here, but it doesn't matter. For the sake of just determining signs, I can put this line wherever, but I'll go ahead and put it kind of close to 178. So the hypotenuse is always positive. This is positive, but this is negative. Okay? Now we just need to determine sine, cosine, and tangent, the signs, because then the other trig functions, the reciprocals, the sign doesn't change. So the sine is what? Opposite over hypotenuse is positive. The cosine, adjacent over hypotenuse, is negative. The tangent is negative, opposite over adjacent. So cotangent is negative. Secant is negative. Cosecant is positive. Okay, 855. Let's see what angle this corresponds to between 0 and 360. What angle is this coterminal with between 0 and 360? So 360 times 2, so 720. 855 minus 720 is 135. So we're in the second quadrant. Somewhere in the second quadrant. Positive, positive, negative. Well, actually, since we know it's the second quadrant, it's going to be the exact same answer as this. Right? Once you determine the quadrant, then the signs of the trig functions are fixed. So this is the answer. Okay, minus 345. So if this is going to be the fourth quadrant. Or no, this is the first quadrant. It's minus. So you go all the way around and you're in the first quadrant, everything's positive. It's an acute angle. Okay, identify the quadrant or possible quadrants of an angle theta that satisfies the given conditions. Okay, so for sine to be positive, so based on for any quadrant, the right triangle that's drawn, sine, the opposite is always the y value. That's why sine theta is defined with the coordinate system. Sine theta is y over r. It's always the y value. So sine theta is positive in the first and second quadrants and negative in the third and fourth. Okay, well, wait. Well, this is cosecant, which is the reciprocal of sine. So we don't get any extra information here. Once we were given this, then that implied this, right? We know the reciprocal of any trig function is going to be the same. The sine of the reciprocal of any trig function is going to be the same sine as the original function. So this is redundant. So all we know is that this angle is in the first or second quadrant. If they gave us information about the sine of another trig function that wasn't the reciprocal of sine, then that would be helpful. Okay, so tangent is, we know it's opposite over adjacent, that's y over x. So when is tangent less than 0? If you think about that right triangle in each quadrant, when is tangent less than 0? When either x is negative and y is positive, or y is negative and x is positive. So when is that the case? Well, okay, here you have both are negative. Here you have both are positive. So it's the second and fourth quadrants is where tangent would be negative. But now they don't give us the information about the sign of cotangent. That would be redundant. We have some useful information here. So where is cosine negative? Well, cosine is the adjacent of hypotenuse. That's the x value. And the x value is negative here. So cosine is negative here. What about here? It's positive here. So this is quadrant 2. Only in quadrant 2 could you have a negative tangent and a negative cosine. Okay, secant and cosecant. So, all right, secant is reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that's radius over x. Okay, cosecant is the reciprocal of sine. That's going to be r over y. So is there any scenario where both of these are negative? Yes, that's going to be the fourth quadrant, right? Or no, the third quadrant, because both you have this is negative and this is negative. But this isn't like a tangent where, you have negative divided by negative is positive. No, they're both dividing by the positive radius. So both of these are negative in the third quadrant. Okay, sine and cosecant. So this is redundant because this is just the reciprocal. So like once they tell us that sine theta is less than 0, we already knew this then. So we're only going to be able to constrain this to 2 quadrants. So when is sine less than 0? So sine is going to be the opposite over the hypotenuse. It's negative in the third or the fourth quadrant. That's when y is negative. Okay, determine whether each statement is impossible or impossible. Sine of theta is equal to 2. Impossible. Why? You can't have a cosine or a sine of an angle be anything greater than 1 or less than -1. Tangent theta is 0.93. Tangent can be absolutely anything from -infinity to infinity. Now, there are situations where tangent doesn't exist, but if they're just asking, is this possible? When it comes to tangent, anything is possible. You could get any real number. Okay, secant theta is -0.3. What is the range of secant? Well, secant and cosecant have the same range. It's -infinity to -1, including -1, in union with 1 to infinity. Well, this is outside of that range, so this is impossible. Now, I'm not going to get into the details again on where this range comes from. We go into detail on this in the previous video. But when it comes to secant and cosecant, you can't get a value that's between 1 and -1. It's like the opposite of the ranges of sine and cosine. Okay, cotangent is like tangent, anything. You could have anything. So this is absolutely possible. Anything you could get any number when it comes to cotangent or tangent. Okay, use identities to solve each of the following. Rationalize denominators when applicable. All right, so find cosine theta given that sine theta is 3/5 and theta is in quadrant 2. All right, so we're going to use the Pythagorean identity that sine squared theta plus cosine squared theta is equal to 1. And where this comes from, check out the previous video. Okay, so if sine squared theta is going to be 9/25 plus cosine squared theta is equal to 1. So cosine squared theta is 1 minus 9/25, which is 25/25 minus 9/25. So that's 16/25. So cosine squared theta is 16/25. So take the square root of both sides, but we need to apply the square root property. So cosine theta is plus or minus 4/5. So now we need more information. Which is it? Well, they do give us more information. Theta is in quadrant 2. So, okay, cosine, quadrant 2, adjacent over hypotenuse, cosine is going to be negative. Right? The x value is negative, so cosine theta, cosine can't be 4/5. If the angle is if sine theta is equal to 3/5, that's possible. You can have a positive, sine would be positive in quadrant 2. So if sine theta is equal to 3/5 and theta is in quadrant 2, well then cosine theta can't be 4/5. It has to be negative 4/5. Okay, so we're going to, same type of question. We want to use the Pythagorean identity to solve this. But what's the Pythagorean identity between cosecant and cotangent? The sine squared plus cosine squared is equal to 1 is easy, but what's this Pythagorean identity? Well, you can just Google it. Make sure you have a reliable Google reference. But remember how we could derive it. So x squared plus y squared is equal to r squared. And so we're thinking about the general definition of trig functions. The whole r, the x, y, and the radius setup. We don't violate with the general definition of trig functions. We don't violate like any rules of a coordinate system to make the definition. Like we use if x is positive, y is positive, y is negative, x is negative. We still honor the fact that if x is negative or y is negative, we honor that, right? We don't like drift off from the actual rules of a Cartesian coordinate system to make the trig definitions. We could define the trig functions to be whatever we want, but it obeys the rules of a Cartesian coordinate system. And same thing with like a radius, a distance from the origin. So what we can do is just say, okay, let's divide both sides by r squared. Or no. We want to, in this situation, we want to divide both sides by x squared, because y divided by x is cotangent and r divided by x is, or no. Y divided by x is tangent. So we want to divide everything by x squared divide everything by y squared because x divided by y is cotangent and r divided by y is cosecant. So we've got x squared divided by y squared plus y squared divided by y squared is equal to r squared divided by y squared. So we can do this. And x divided by y. For x could be negative, positive, y could be negative, positive. This is, just a full coordinates. This obeys the coordinate system, Cartesian coordinate system. So we just say x divided by y is cotangent squared plus 1 is equal to cosecant squared. So 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so it tells us that cotangent is minus 1/2. So 1 plus minus 1/2 squared is 1/4 is equal to cosecant squared theta. 1 plus 1/4 is 5/4. So cosecant theta is root 5 over 2, or plus or minus root 5 over 2. So which one do we use? Well, okay, we know it tells us we're in quadrant 4. Okay, cosecant is hypotenuse over opposite. So we're dealing with the y here. Y is negative, so cosecant is going to be negative. Okay, here we're not going to use a Pythagorean identity. We're going to use the quotient identity. One of the quotient identities, one of the two quotient identities. So if we know that sine theta is 1/2, well, no, okay, we might use a Pythagorean identity as well. So, all right, sine squared theta plus cosine squared theta is equal to 1. Now let's divide this entire equation by, well, no, that's not going to do anything. Well, okay, okay, sine squared theta is 1/4. Okay, 1 minus 1/4 is 3/4. So cosine theta, well, plus or minus, is plus or minus root 3 over 2. All right. So, but which one? So we're in quadrant 2. So cosine is going to be negative. So we know that cosine theta is minus root 3 over 2. Okay. But we know that tangent theta, based on the quotient identity, is sine theta over cosine theta. So what is sine theta? Sine theta is 1/2 divided by cosine theta. So we do minus 2 over root 3. So minus 1 over root 3. Now we want to rationalize this. So it's minus root 3 over 3. So tangent theta is minus root 3 over 3. All right, so the Pythagorean identity is 1 plus cotangent squared theta is equal to cosecant squared theta. So, okay, 1 plus cotangent squared theta is equal to, so cosecant squared, so 1.45 squared, 2.1025. Okay, so cotangent squared theta is equal to 2.1025 minus 1. So cotangent theta is equal to plus or minus 1.05. But which one? So quadrant 3, x and y are negative, so cotangent is going to be positive. And And that's it. That's what we're looking for. Okay, give all 6 trigonometric function values for each angle theta. Rationalize denominators where applicable. All right, so it gives us the tangent of theta. And it also tells us that we're in quadrant 2. Okay, so let's use trig identities to find, any trig function, any other trig function. So when it comes to Pythagorean identities that involve tangent theta, we've got 1 plus tangent squared theta is equal to secant squared theta. So 1 plus 15 squared is 225. 225 over 64 is equal to secant squared theta. So secant squared theta is, 64 over 64 plus 225 over 64. So 289. Right? So secant theta, what is 289? Square root of 289. So is 17. So plus or minus 17 over 8. All right. But which one? So we're in quadrant 2. So secant is going to be, that's the reciprocal of cosine. Cosine's adjacent over hypotenuse. So secant's going to be negative. So secant theta is minus 17 over 8. Okay. Now, what else can we do? Well, we could have done this in the beginning, but cotangent is going to be minus 8 over 15. It's that easy when it comes to reciprocals, unless you're dividing by 0. The reciprocal results in dividing by 0. So there we go. Okay. Now, we can do the same thing here. The reciprocal of secant is cosine. So minus 8 over 17. Okay, now we can use the quotient identities. So tangent theta is equal to sine theta over cosine theta. And so sine theta is tangent theta cosine theta. So sine theta is tangent theta cosine theta, which is, minus 15 over 8. And cosine theta is minus 8 over 17. So sine theta is 15 over 17. So we've got sine, cosine, secant. So we just need cosecant. That's 17 over 15. There we go. Now notice though, so we could have also done, once we had like secant, for example, that's hypotenuse over adjacent. What we could have just put, so the hypotenuse, we could have put 17 and then put minus 8 and then just use the Pythagorean theorem to solve for the other side, and that would have worked fine because it's all ratios. So again, we could, once we had like secant, we would still need to know, have information about we can't just have one trig function, I don't think. And now we can get all the other trig functions unless we have at least some information about the quadrant, because we would need to, like, okay, so if we had secant theta, we know that the hypotenuse is 17 and this is, and the x is minus 8, and we could use the Pythagorean theorem to get this side, but we wouldn't, without the quadrant, we wouldn't know whether or not to put this side positive or negative unless it told us the quadrant, or unless we had another trig function that gave us that information. But in general, if you're given secant in any trig function like this, the value and a quadrant, then like we were here, we were given a trig function value and the quadrant. We didn't actually need to use any trig identities. like, let's go to the next problem. We'll do it that way. So, okay, we're given the value of a trig function and the quadrant of the angle. Now we can get all the trig functions, and we just did that, but we don't have to even use trig identities. So we've got, this is quadrant 1. I wish we had another quadrant with a negative value, but it wouldn't, even if we had any quadrant, even with negative values, it would work the exact same. So, okay. So we know that it's saying sine of theta is root 5 over 7. So that's opposite over hypotenuse. So we know the hypotenuse is, we can put 7. I'm not, it doesn't mean that it is 7. Like whoever, let's say someone derived this. Does that mean that, like, you could make the right triangle be whatever size you want? It doesn't mean that the radius is 7, but as far as ratios, as far as the like we can do this, okay? But we need to know that's quadrant 1 because, okay, if it was, let's say it was quadrant 2, or let's say it didn't tell us, right? Let's say it didn't tell us the quadrant. Well, let's draw a triangle in quadrant 2. Okay, and it gives us that this is the sine here. Well, okay, but this is useful because we can put 7 and we know it's positive y. This is true because otherwise it would, it would be negative if it wasn't positive y. But then, okay, what we're going to do next is we can use the Pythagorean theorem to get the other side length. So root 5 squared is 5 plus, we'll say, x squared is equal to 7 squared is 49. So x squared is 44. Okay, 4 times 11 is 44. So plus or minus, which one? It could be either one of these. So we don't know, right? But since it tells us quadrant 1, we know it's. So we can just, this we already knew it was quadrant 1, but so there we go. Now we can use this. There's the angle theta. We can get all the trig functions just reading off the triangle, right? Like, yeah, like cosecant is 7 over root 5, but we could just look at the triangle. So cosecant is hypotenuse over opposite. So 7 over root 5, but we want to rationalize that. I mean, obviously, you'd always just go to the reciprocal. That's very easy, but we're trying to, absorb these concepts. So I'm just looking at it showing you this from different angles. So, okay, 7 root 5 over 5 is cosecant. All right, tangent is opposite over adjacent. So we've got root 55 over 22 is this. So 5 times 11, no, that's it. So now cotangent, we would just take the reciprocal, but let's just come to the triangle. Well, we're going to have to do the rationalizing anyway. So 22 over root 55. So we've got cotangent is equal to, so root 55 over root 55 times this is 22 root 55 over 55. And actually this is, so divided by 11, this is 2, so 2 root 55 over 5. That's cotangent. So sine, we need cosine, adjacent over hypotenuse. And then secant is 7 over 2 root 11. So 7 over 7 root 11 over 22. And there we go. All the trig, just pause the video. All the trig functions are in there. Okay, we can do this either way. We can use trig identities, or we can do what we just did in the previous for the previous problem. Let's do trig identity. So 1 plus cotangent squared is cosecant squared. So 1 plus square root of 3 squared is 3, 8 squared is 64, is equal to 64 over 64 plus 3 over 64 is 67 over 64. So cosecant is plus or minus. Okay, which one? Well, in quadrant 1, all of the trig functions, every single one is going to be positive. Okay, so what we could have just said, we see that tangent theta is going to be 8 over root 3. We need to rationalize that. 8 root 3 over 3, so okay, cosecant, that means sine of theta is equal to 8 over root 67. So 8 root 67 over 67. Tangent, cotangent, and then cosine is going to be, so, okay, the quotient identity, tangent theta is equal to, so cosine theta is equal to sine theta over tangent theta. Sine theta is 8 root 67 over 67. Tangent is 8 root 3 over 3, so we're going to do 3 over 8 root 3. So 3 root 67 over 67 root 3. So, okay, 3 times 67. And does that have... No. So 3 square root of 201 over, and then 201, and then 201 divided by 3, 67. So cosine theta is square root of 201 over 67. Okay, and so inverse reciprocal cosine is secant. So 67 over root 201. That's going to be, so it's taking forever. 67 over is root 201 over 3. Okay, so if sine theta is positive, we could use trig identities, but let's try and do this without trig identities. If sine theta is positive and cosine theta is negative, that means we're in this quadrant 2, right? Opposite over hypotenuse is positive, adjacent over hypotenuse is negative. So sine is opposite over hypotenuse, so that we can make the hypotenuse 6 and this root 2. And now we can use the Pythagorean theorem to get this, but we're going to make it negative, though. That's the key. So root 2 squared is 2, plus x squared, we don't know, is equal to 36, 6 squared. So x squared is equal to 34. So x is equal to 34 is 17 times 2, so that's it. But we know this is going to be negative. Right? And so there we go. This is the angle. But we come here and we say, okay, so what's cosine? Adjacent over hypotenuse, minus root 34 over 6. What's tangent? Root 2 over root 34. Or that's going to be minus, so minus. So this is minus 2 over 34. So minus, and this rationalizing takes forever. So it's going to be minus root 17 over 17. So tangent theta. Okay, and now the reciprocal of sine is cosecant 6 over root 2. That's 6 root 2 over 2, 3 root 2. Okay, cotangent is minus 17 over root 17. All right, so minus 17 over root 17 is minus root 17. Okay, and then secant is going to be minus 6 over root 34. Minus 3 root 34 over 17. Okay, sine theta is equal to 1. This is a little different. When is sine theta equal to 1? Well, sine theta is the opposite over the hypotenuse, so it's the y over the r. So if it's equal to 1, that means y is equal to r. That's only here. When theta is equal to 90. It's not here when theta is equal to 270 because in that case, y is equal to minus r, so sine theta is equal to minus 1. So the trig functions, what is cosine 90? That's 0. Okay, what is reciprocal of sine is cosecant is 1. What's tangent of 90? Well, you think opposite over adjacent. Adjacent is 0, so undefined. But cotangent is 0. Adjacent over opposite. Opposite is the radius. So cotangent is 0. And then reciprocal of cosine is secant. Radius over adjacent. Adjacent is 0, so undefined. Okay, suppose that theta is between 90 and 180. Find the sine of each function value. Well, here, if theta is in the second quadrant, here, but you multiply that by 2, what happens? Well, 180 times 2 is 360. 90 times 2 is 180. So you're going to be either in the third or the fourth quadrant. Sine is opposite over the hypotenuse, the radius. Radius is always positive, so it's the y value. Well, the y value is negative in these two quadrants, so this is negative. Okay, theta divided by 2. If we think 90 divided by 2 is 45 degrees, 180 divided by 2 is 90 degrees. But it's between those two, so we're not going to be at 90 or be at 45. We're going to be somewhere in here. We're going to have an acute angle. All trig functions of acute angles, every single trig function is going to be positive. Okay, theta plus 180, so theta is between 90 and 180. If you add 180 to theta, you get 360. If you add 180 to 90, you get 270. But where it's between 90 and 180, not equal to, so it's going to be in the fourth quadrant. Like, it's not going to be a quadrantal angle because this isn't less than or equal to. So the fourth quadrant, what's cotangent? Cotangent is adjacent over opposite, but okay, we're going to have a positive x and a negative y, so this is going to be negative. Cotangent and tangent. Well, reciprocals are always the same sign anyway. Okay, cosine of negative theta. Theta is between 90 and 180, so we are going to be in the third quadrant. Right? Somewhere from negative 180 to negative 90, somewhere in here. Third quadrant, you have a negative x and a negative y. So both cosine and sine are going to be negative. So this is going to be negative. Okay, suppose that theta is between minus 90 and 90. Find the sine of each value. So from minus 90 to 90 is going to be the first or the fourth quadrant. The x value is positive. That has to do with cosine. This is always going to be positive. Okay, theta plus 180. So minus 90 plus 180 is positive 90. 90 plus 180 is positive 270. So we're going to be in the second or the third quadrant, which x is always negative, and y could be positive or negative, but secant is the reciprocal of cosine, so this is always going to be negative. Okay, negative theta, so we're going from, this would be 90 to minus 90, so is that going to be the, what would that be? If we had like, okay, if we had theta is equal to 45 degrees, that'll be minus 45. So yeah, it's going to be the first or the fourth quadrant. So and then secant is cosine or hypotenuse over cosine, and so this is always going to be positive. Okay, theta minus 180. So minus 90 minus 180 is minus 270. So minus 270 is here. And then 90 minus 180 is minus 90, so here. So it should be either quadrant 2 or quadrant 3. Is that right? So if theta is equal to 0, what are we at? Minus 180. Yeah, so, okay. Cosine is adjacent over hypotenuse, so this is negative. So, okay, always negative. Okay, find the solution to each equation. So we want to solve for theta. Well, how in the world can we do this? Well, let's think about the reciprocal identities. You might say, well, how can we apply the reciprocal identity here? This is just a variable, right? You could say that z is equal to 5 theta minus 8. So we have cotangent of z. Well, what is cotangent of z? It's 1 over tangent of z, right? So what I'm saying is it makes complete sense to apply the reciprocal identity here and just say that this is tangent. Well, okay, if these two are equal, then the arguments are going to be equal in the tangents. So we could just set the arguments equal to each other. Okay, subtract 3 theta from both sides. Okay, add 8 to both sides. Divide both sides by 2, so theta is equal to 2. Okay, so cosecant is the reciprocal of sine, so we can, this should work in that we could divide both sides by, we'll do this. We'll divide both sides by so these cancel. You've got sine 4 theta. Okay, now 1 over cosecant of 3 theta plus 5 is going to be sine of 3 theta plus 5. So now we just set these two arguments equal to each other. Okay, subtract 3 theta from both sides. Subtract 2 from both sides, so theta is equal to 3.